Hello everyone, welcome to our weekly CBSE Class 10 chapter wise series. And today we will carry on with the chapter Real Numbers. This is part 2 of the chapter. In part 1, we have already covered the concept of HCF and LCM, and we will carry on from here. Now we come to the word problems based on the concepts of HCF and LCM. The statement of the question is six bells commence tolling together and toll at intervals of 2, 4, 6, 8, 10, and 12 seconds respectively. When will the bells toll together next? Let us understand what is the meaning of this word. So here the word commence means start and toll means rings. So six bells start to ring together. So let us understand using two bells, let there be bell 1 and bell 2. Now here we are assuming that they start together and they ring after every 3 second and 4 second. What does that mean? That at 0 second both the bells start, but then bell 1 will now next ring at 3 second, 6 second, 9 second, 12 second and so on. The bell 2, which also started at 0 second, but since it is ringing every 4 second, will next ring at 4 second, 8 second, 12 second, 16 second and so on. Now if the two bells they ring together, at what time earliest are they ringing together? So here I can see they are ringing next together at the same time at 12 seconds. So what actually we are calculating? We are calculating nothing but the LCM of 3 and 4. So the same thing is happening in our problem. Here the bells are all ringing at 2, 4, 6, 8, 10, and 12 seconds respectively. So we find the LCM of these numbers to find out when they will again ring together. So the LCM of these numbers is 120 seconds, or we can also write 2 minutes. So all these six bells will again ring together after 2 minutes. Let's see the next question. A merchant has 120 liters of and 180 liters of two kinds of oil. He wants to sell oil by filling the two kinds of oil in tins of equal volumes. What is the greatest of such a tin? So let me explain you the question. Suppose I am having two containers. One is having 30 liter of oil and another is having 40 liter of oil. I want to sell them in small tins, but then the tins must be of equal capacity. And what should be the greatest size of such a tin which can occupy 30 liter and 40 liter together? Now 30 liter can be contained in a container of 1 liter also, 2 also, 3 also, 5, 6, 10 and 30. Correct? 30 liter can be contained in all these combinations. Likewise, 40 liter can be contained in 1, 2, 4, 5, 8, 10, 20 and 40. Now, of all the different combinations, which are the common combinations? So, they can be contained in 1 or 2 or 5 or 10. And out of all of them, which is the greatest of all? That is 10. What is 10? It is nothing but HCF of 30 and 40. So, to find out the tin which is of the greatest capacity and can contain both 120 and 180 liter, what we have to do? We have to find the HCF of both the numbers. The same explanation. So we find the HCF of 120 and 180, which is 60. So the greatest volume of each tin is 60 liters. Now a very important tip to identify what kind of questions will have LCM and what kind of questions will require us to calculate the HCF. So if the required answer of the question is greater than all the given values in the question. For example, here we know that the bells will toll together next only after 12 seconds or even higher than the 12 seconds. In such questions, we find the LCM. All such questions where the required value is smaller than the given numbers. We know to find the size of the tin which can contain both 120 and 180 liter, the size has to be smaller than them both. In such questions, we find the HCF of the given numbers. I hope this will help you to solve more such word problems. Now, using this concept and the previously discussed concept, we can solve all questions from exercise 1. Now we move on to the next theorem, theorem 2. It says let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. This is something that we understand, but here it has been given to us in the form of theorem. We'll be using it for the next theorem. But let us first understand what does it mean. Let us say that p is 3. and 3 is a prime number, correct? We know that 3 is a prime number. Now they are saying if p divides some numbers square. So if, let's say, p divides 81, does it divide 81? Yes, it divides 81, and 81 is nothing but 9 square. So if I know that p divides 9 square, that what can I can conclude? I can say p divides 9 as well. So since 3 divides 9 square, 3 will also divide 9. So this is what the theorem is. We can try with another prime number, for example 2. So if 2 divides, let's say 64, 64 is 8 square, right? So if 2 divides 8 square, what we can conclude? Using this theorem, we can conclude that 2 will divide 8 as well. I hope this is very clear, because this theorem we'll be needing for proving the next theorem, which is a very important theorem. So the next theorem is prove root 3 is irrational. Now we all know that root 3 is irrational, but how do we prove that root 3 is irrational? So to prove this, we use a concept which is called contradiction. Now what is the meaning of contradiction? Contradiction means assuming the opposite of what is given or what we need to prove, and then on further solving getting some incorrect results. What will that incorrect result indicate? That what we have assumed in the beginning was incorrect. That is why we are ending up getting incorrect results. So this is the concept of contradiction. The basic idea is if you start wrong, you will end up at a wrong step. Let us see how we use contradiction to prove root 3 is irrational. So because they are asking us to prove root 3 is irrational, I'll assume that root 3 is rational. And since it is rational, it can be written in the form of p by q, where q cannot be 0 and p and q are co-prime integers. This is a very important statement here. Now what do I mean by co-prime integers? The integers or numbers that have no common factor other than 1. The only common factor which p and q here have is number 1. Fine. Let's move on. So I have written root 3 as p by q. Cross multiplying, I am getting root 3q as p. Now I square both the sides. What will I get? I will get 3q square is equal to p square. This becomes my first equation. And on rearranging, I can write q square is equal to p square by 3. What does it mean? It means that 3, when it is dividing p square, it is giving me some quotient q square. So here it means 3 divides p square. Now we have just now studied a theorem that if p is a prime number and it is dividing some square of a number, then it will divide the base also. So since 3 divides p square, 3 also divides p. Correct? Now if 3 divides p, that means when p is dividing 3, I am getting some integer quotient. For example, if I say 2 divides 10, what does it mean? It means that I am getting a integer quotient 10 and my remainder is 0. That means I can write 10 as a multiple of 2. Similarly, since 3 divides p, I can write p as a multiple of 3, where c here, which I have taken, is some integer. Now this value of p is equal to 3c, we will put in the first equation. What I will get? We will get 3q square is equal to, in place of p we write 3c, 3c the whole square. Open the brackets, 9c square, divide by 3, 3c square, and on rearranging we get q square divided by 3 is c square. Again, what does it mean? It means 3 is dividing q square, and from the above theorem, since 3 divides q square, 3 divides q as well. Now from equation 2 and equation 3, I am getting 3 divides p and 3 divides q. What does it mean? It means that 3 is a factor common in p and q. But what? We started by assuming that p and q have no other common factor than 1. And here what we are getting? 3 is a common factor of both p and q. That means we have come to a contradiction. We have come to a wrong result because we started with a wrong assumption. Since p and q are not co-primes, therefore our assumption is wrong, and therefore by contradiction we can say root 3 is irrational. I hope all of it is understood. This is what is irrational. If you start at the wrong path, there is no possibility that you can end up getting the correct destination. That is what exactly we are doing here. Since we are starting incorrect, where we are ending is also incorrect. And this is what is contradiction. It's a very important question from exam point of view, And one such question is definitely asked from this chapter in the final exams. I hope we can move on. Now, before going to the next concept, we need to refresh some of the concepts we have learned in class 9. This is about the operation between rational and irrational numbers. So if I am having two rational numbers and if I add them both, the result will also be a rational number. If I multiply, if I divide, if I subtract two rational numbers, the result will always be a rational number. Understood? If I'm having a rational and an irrational numbers, we know rational and irrational, they cannot be further added or multiplied. But the result that we get, a rational and an irrational number will always end up getting a irrational number. Root 2 divided by 3. This is irrational number. Fine. Now, the operation between two irrational numbers. Suppose I am having root 2 plus root 3. What am I getting? I am getting an irrational number, correct? But if root 2 is irrational, is negative of root 2 is also irrational? Yes. And if I add them both, what do I get? I get 0, which is a rational number. Okay, let us take another example. If I am having root 2 times root 3, what result I'll get? I'll get root 6, which is another irrational number. But if I'm having root 2 and I'm having 2 root 2, both these are irrational numbers, but when multiplied together, they result in 2 2s are 4. That means a rational number. So a very, very important understanding here, that operation between two irrational numbers may result in a rational number or an irrational number. This one statement is asked several times in the exams also. Okay, so let us move further. Now we have to show that 2 plus 3 root 5 is irrational, where we are having operation between a rational and an irrational number, considering root 5 is irrational. Again, we will solve this using contradiction, and we will assume that 2 plus 3 root 5 is rational, can be written as p by q, q not equal to 0, and p and q are co-prime integers. Hence, we write 2 plus 3 root 5 as p by q. Now, these questions are simpler because our main objective in this question would be to move all the rational values to the right side and leave the irrational part of the question on the left side. So, we will try to keep root 5 on the left side and we will move 2 and 3 to the right side. When we rearrange, we get 3 root 5 as p by q minus 2. On taking LCM, we get p minus 2q by 2. And when the 3 is moved to the other side, we get root 5 as p minus 2q by 3q. Now understand, here your left hand side is root 5, which is an irrational number, and the right hand side that has operation between p and q is actually a rational number. So here we are trying to say that an irrational number is equal to a rational number. This is not possible, and therefore we have landed up in a contradiction. Therefore, our assumption that 2 plus 3 root 5 is rational is incorrect, and so by contradiction, the value 2 plus 3 root 5 is irrational. I hope this is understood, and this much of theory is needed to attempt questions from the chapter. Thanks for watching part 2. The discussion of this chapter is divided in 3 parts. We have already completed part 1 and link to it is given in the description. We completed part 2 today, and using these concepts we can solve exercise 1.2 as well. In part 3, we will solve some additional practice questions from exam point of view. So stay tuned. Thanks for watching. Do like, share with your friends and subscribe to get all updates in time. In comments, you can send your doubts or your feedbacks. Enjoy learning.